Alright guys, I figured I'd just share with you what's in this box and talk a little bit about what we're doing to what's in this box. So, let me unwrap it and then I'll talk about it as I go. Supercharging. Well, typically most of our channel right now is S2000s. It's almost like the latest generation knows us for S2000s. A lot of people don't realize I've been doing this since '96, and I gotta say, I kinda, as they say, cut my teeth on the Jackson Racing supercharger. I was one of the first to put a GSR with a Jackson Racing supercharger in a CRX. And of course, being a performance guy, I kept pushing it and pushing it, pushing the limits. And of course, supercharging produces a lot of heat. The more boost, the more heat. It's almost like the more you push it, the less the returns. It's parastatic loss, it's heat. It's so many factors are working against you. One of the problems is heat and pressure. Well, the supercharger, first off, isn't a compressor, it's a pump. A pump doesn't like pressure, it doesn't like to compress air like a turbo or a typical compressor style wheel. It likes to pump, which means it likes to pull air from one side of it to the other with as little restriction as possible. So some of the high horsepower builds that I did, when I would explain to people I'm making 300 wheel horsepower at 8 pounds of boost, their first thing would be, why don't you up the boost? Well, it becomes a restriction, it becomes a resistance, and it makes everything increase and you don't get the return. So I had the supercharger, I would push the limits to a point where it would hit a certain horsepower and my IATs would go through the roof, intake air temperature, because it's compressing air in here, it's causing a restriction. As the intake airs increase, the less power you make, there's less oxygen in the molecules, you can't make as much power, there's no energy in hot air as opposed to cold air. So I took one of these, I took it to the blower speed was maximum, I think about 15,500 RPMs, and I was creating this pressure and heat and I couldn't make any more power. So I took one of these, and the very first one, I'm gonna see if I can find the pictures, because I have a lot of pictures of this stuff. Several computers ago, so I gotta make sure I can find the footage. I took one of these, very, very simple, drilled a big hole in each side, and got a big aluminum tube, and routed it through here, and routed it back, and ran ice water through here, put it on the dyno. It immediately made power. Mid-power, my air-fuel ratio leaned out. I was on the way to an intercooler. I'm cooling the air. Problem is, having a tube this size, there isn't as much surface area. You can't pull as much heat out of it. There isn't as much what we call surface tension, just having a smooth tube. I kept building it, changing it, adding on. This was going back '97. I made a sandwich plate between this from a Spearco intercooler, ran water this way, it spaced the supercharger down, ran into all kinds of other issues. The problem is I'm forcing air through an intercooler this big, which should have really been this big. So I'm running into an air pressure problem. It's cooler air, but now it's not as efficient. So next thing, bolting it back on here, I cut the whole roof off, had the air push through the back here. Imagine this here. The supercharger is pushing air here. This is the air going into the cylinder head. So imagine cutting this roof off, and this back section here, I'm pushing air off on this angle. I made this whole top section an intercooler, the full width of that. So imagine an intercooler sitting up here. It would push around through the intercooler, back through here, out of here. I went through a few different courses. I spent tons of money. I learned how to weld aluminum so good because I was certified to weld stainless and mild steel and pipe weld, but I didn't have a lot of experience with aluminum at the time. So let me cut to the chase. We're going to start making the manifolds again. We did take about a 2-year hiatus from this just for several reasons. Machining costs. We got pretty backed up and a little short-staffed. We couldn't keep up with building these things. Here it is. What we're going to do is you send us your manifold. Right now it's B series only. Send us your manifold. Make sure it's in good shape. If it has cracks, get a hold of us ahead of time. We'll look at the cracks, give you an estimate on repairing the cracks. Make sure it's not powder coated. If it's powder coated, we can't do it. You're gonna have to strip it. We still have our hot tank process and bead blast process, but if it's powder coated, we can't do it. If it's painted, go ahead and strip as much of that as you can, so you're not paying us to do it. I have to pay to get that done. What you're gonna do is fill out a piece of paper, something like this. We need your name, address, phone, email, whether it's a B16/ITR or it's a GSR. The payment for this is $10.95. That includes return shipping. This is the USA only. We're gonna ship it back to you, UPS, just as you see it right here. Strip the manifold off, take all your fittings off here, take your bypass valve off here. We don't want any of that stuff. It's hard for us to keep track of all the little knickknacks, whether it came in with a broken part or a missing part, or if it was bent. Remove all those parts. You're gonna get your manifold back. So make sure your manifold is in good shape. That's the one you're gonna get back. It's gonna look like this. Right now, all we're doing is the B series ones. We will be doing the D series soon, and then the H series. But right now, just till we get caught up, we're gonna be working on the B series only. Turnaround time is 30 days, more than likely less. But the machining, the hot tanking, the beading, everything like that, we have to check each one. There's a lot more into the process, and a lot of back and forth between different processes to get the manifold done. So allow 30 days. We're trying to shoot for less than that, but give us 30 days. That way each one has 100% attention. We can make each one look perfect. So real quick, little crude drawing. I just wanted to kind of explain how the intercooler works. It's a water to air heat exchanger. So what is happening, this is your manifold. Your supercharger is here, putting hot air into here. What we're doing is drawing the hot air, pulling it into water, then exchanging it into the atmosphere. So basically, this is your manifold. It's gonna have a water pump and a heat exchanger. Heat exchanger is basically a radiator. It does what it sounds. It exchanges heat. It goes from hot air, disperses it as the air passes through it, pulls the temperature out of here, pulls the temperature out of the water, and in effect, pulls the temperature out of the air. So basically, manifold hooks up to the water pump goes to the heat exchanger. This is optional, either a reservoir, which is just a small body of water that will allow you to bleed out the system, or an inline filler. But this again goes to the heat exchanger and then back to the manifold. Once this pump is switched on, we typically activate it with an ignition source. This circulates water. As the air passes through this, it pulls the temperature out, cools the air passing the manifold. As the air goes in there, cool air comes out. Alright, so to demonstrate this, I'm going to show you, this is a manifold we just welded up. It hasn't been cleaned yet, hasn't been polished. But what we did, went to Walmart, got myself a hairdryer. This is an 1875 Pro, by the way. We're not doing the cheap one. Actually, it's the cheapest one they had. We're using a bilge pump right now just so we can submerge that in water. This will produce water over here. The attachment that came with this was a diffuser of some nature, and basically just made some tabs here, attached it to there. That's one of these things that has the little prongs on it. Sanded it off, so basically turned it into a manifold. This is the thread I'm talking about. Just put a bolt in there with some PTFE tape, Teflon tape, so that way we can force our hot air through here. Set this up. I made a little tab here, got a little thermometer right here. We can put this on here and measure the air coming out of here. Now, when you're logging this on your Data or something like that, you are measuring using this temp sensor back here. Now, if you think the way this system works, the heat is coming up here and making a turn. You're measuring on this port right here. You're only seeing half of the core. You've got two cores right here, so you're only measuring the temperature drop on half of one core. When we did our original data testing, we put our IAT sensor in here and measured this port right here. We got much more dramatic results of intake air temp as opposed to the factory spot. This is where you're actually seeing the temperature. All right, so we have our manifold set up right here, and we have our hair dryer right here, which we're gonna call it a supercharger because it acts like a supercharger. Is blowing air up here. So this gauge doesn't react very fast. So we're gonna use our digital temperature gauge on this so we can watch it. What I'm gonna do is run the hair dryer supercharger. I'm gonna run it for a full minute before we do anything. What I've done is hooked up the hoses. We have a little bilge pump right here. This is the return hose. This would be going back into the system. I just put this on so we can see it. So we can run this pump and see the water coming out of here, and hopefully should see a noticeable temperature drop. Now, this is just ambient temperature. It came right out the tap. It's been sitting here for about half an hour, so it's pretty much ambient. So you're not going to get cool and ambient. A lot of people are going to say, well, I would thought it makes the temperature go down to 70. You can't get lower than ambient unless you chill the water either with ice or some nature like that. So we should see ambient, which right now is 91. I'm guessing that hairdryer is probably going to take it to 120 degrees, which is still nowhere near what a supercharger puts out at about 10 pounds of boost. About 200 is where we're maxing out at here. All right, so we've got our little bucket set up, got our bilge pump in here, got a 12 volt battery. This is so we can see our water flow. There we go, it circulates. So this is how we have it set up right here. Okay, so we're getting a pretty good temperature drop. Depending on where I point the temperature scanner, it's bouncing around, but it's mid 90s, 93, 94, 95, somewhere around there is a pretty good drop on the intercooler port right there. Alright, so hopefully you enjoyed the test. It kind of explained how this works. So this manifold is actually going to a YouTuber. He is called Eric. His YouTube channel is Eric the Car Guy. Check him out. We got to talk on the phone, and I felt like me and him could hang out all night and talk cars. He thinks, we think a lot alike. He's building an Integra Type R with a Jackson supercharger, and he doesn't want to be the king of the horsepower guy. He doesn't want to go burn the tires off and making it unreliable. He gets the balance part of it, meaning a fun car that's fun to drive, but it's not going to break every 5 minutes or break the tires loose every time you hit the gas. There is a little bit of fun in spinning the tires, but you want to actually use the power too. So really nice chatting to him, and it's going to be a good build. Check him out, Eric the Car Guy. I think he's building the car later in the year, but it'd be a good demonstration because he's going to basically he's going to bolt this thing on, and I've kind of given him some tips of what parts he's going to need to make the build easier. We're planning on building the B-Series throttle body, the GSR style. Pulls the cable in a different direction, fits much nicer. It's a 70mm throttle body. OE quality. It's not one of those ones that stick, the big billet one that weighs like 10 pounds and the throttle blade sticks and it's just awful. Get a hold of us if this is something you want to do. The information, all our addresses on the website. The website, there isn't an ordering process on the website. Do it the way I explained with the paper. We'll contact you and we'll get a payment for you and we'll make one of these things work for you. Sound good? Thanks for watching. See you on the next video. Don't forget, enjoy your cars and enjoy your supercharged car.